Good morning, everyone. My name is Tom Reed. I'm the program manager for the Energy and Manufacturing in Appalachia program. I am going to do a brief introduction, and while everyone gets a chance to get signed in and make sure your volume and everything is working correctly. So just to get things started off, I just want to welcome you all. If you haven't been to one of our EMA webinars or events or to our website, welcome. We are here. We cover 156 counties across 5 states, and it's helping small, medium-sized manufacturers to enter or expand their efforts in the energy supply chains or to be more energy efficient in their own production. But for today, we kicked off in June the start of our energy supply chain overviews. And this is where we have asked knowledgeable people to author reports in a variety of energy supply chains. And the goal of each report is to help you, the manufacturer, determine if this is a go or no go opportunity for you. So you get a chance to download the reports, take a look at them. There are a lot of links to help you to make connections for further details, but it's kept in a concise focus. And so we have several that are out there now. If you look over to the right side of the screen, natural gas carbon capture, nuclear, and onshore wind are all available now for you to download. And we have recordings of the webinars online that you can watch those playbacks to kind of hear from the author. Usually they touch on some of what's in the report and help you to kind of learn more about what you'll dig into in the report itself. Coming up, we have a great list here. August 21st, we have battery storage. September 11th, we'll have the second part of our AI data centers series that you're here to hear about the first part today. September 25th, natural gas upstream. Then on October 2nd will be the third part, AI data centers advanced cooling. November 6th will be geothermal. And then the fourth, and at this point, what we have on schedule will be the fourth of our AI data centers, and that will be steel infrastructure. So each of those today is going to be the overview, but each of those will dig in a little deeper into a specific area of the AI data centers. As you all know, there's billions, near 100 billion of investment coming just to the Pennsylvania area across these multiple states. I'm sure it's going to be a multiple of that. So hopefully you all are learning and downloading these reports to see how we can help. So how do you further that? Go to the wemakeithere.org/energy, and you can see all of this information. You scroll down under resources. That's where the reports are. And if you look at our events, we will have sign up registration pages for all of these upcoming events. So enough of me talking. I want to introduce you to today's speaker, and that is an author, is Dr. Deborah Stein. She has quite an impressive resume. I'll hit some of the highlights. She was the founder of the Science and Technology Policy Academy. She served as the executive director of President Obama's Council of Advisors on Science and Technology. She's a science and technology specialist at the Congressional Research Service, a study director at the National Academies of Sciences, Engineering, Medicine, and as a professor of the practice of engineering and public policy at CMU. So if that's not impressive enough for you, I don't know what else we could offer to you today. But I want to turn it over to you, Deb. Thank you for putting this together. And AI data centers is definitely a hot topic right now.
Yeah, thanks a lot, Tom. And I really enjoyed working on this project. Of course, as a daily user of AI, it's really kind of interesting to see, how I interact with that system every time I make a query. And then, of course, that also affects our energy system. So, as Tom mentioned, this is the very first one. This is an overview. And then I have three more presentations coming up that are going to be more in depth, again, from a manufacturer's perspective. looking at power and electrical infrastructure, advanced cooling and thermal management, and then structural steel racking and enclosures. So this is just a few of the headlines this month that have talked about data centers. And it's something that is just really, really big in our area. In this region, not just, of course, in Pennsylvania, but in Ohio, West Virginia, New York, all throughout the region. So this one, for example, is about the data center boom inspiring flurries of bills from Pennsylvania lawmakers. West Virginia, I do a lot of work in West Virginia. There's been a lot of work that's there. And then you'll see here that, of course, President Trump was here on July 15th for a big event at Carnegie Mellon, where he talked about data centers. But data centers also have some of their challenging side, and you're going to see this as I chat today, because the data centers really take a lot more energy. You can see just the bottom picture there is this big AI campus that's being built in Ohio. And you can see that's like 4 buildings. And data centers are basically a big giant building. So it's not the buildings that are really the big focus, but what's inside those buildings. So the overall goal of this project is to provide support for small and medium-sized manufacturers who are interested in providing components for the potential market opportunity presented by AI data centers, not only in our region, but nationally and also globally. So this is definitely a big global activity. So today I'm going to talk about what is a data center, 7 things you need to know, talk about some of the components, look at some of the emerging technologies that address some of the energy and environmental challenges, some industry resources for those of you who'd really kind of like to take the next step on this, and then we'll have Q&A at the end. So you should feel free to enter questions as we go along in the chat. You can also put them in the Q&A function. So what are AI data centers? They're specialized facilities that are designed to support the intensive computing and data storage needs of artificial intelligence or AI applications. Here's an example of the exterior of one. This was in the New York Times back in June. This is Amazon's biggest data center. As you can see, it's 1,200 acres on a cornfield in Indiana. And you can see those kind of multiple buildings, sort of like that one that I was showing, which was a mock-up for one in Ohio. And what it's serving is Anthropic, which is one of the AI tools that are out there. Other ones are Claude, ChatGPT, Perplexity, which is currently my favorite. And they really just, as you use them, it does end up using a lot of energy and a lot of resources. And the challenge is that some states have sort of like maxed out on what they can provide, and that's why people are coming to our region. So here's the interior of a data center. You can see there's lots of things to kind of help manage the heat. You'll see cooling units, air conditioning, heat exchangers. Then there's backup generators, because most of these things really have to be 24 hours, 7 days a week. No, you don't want the power to go out. So then you have what are UPS systems, which are uninterruptible power units. Then you have network operation centers. That is what does the IT and security. And of course, concrete and steel construction that are around this entire thing, as well as the racks that are used in the server room to hold the computers. So you can see, just from a manufacturing standpoint, there's lots and lots of widgets that are part of this, part of data centers. The other thing I want to think about is where the energy is coming that support these data centers. So this is an interesting analysis, kind of looking at that aspect. So most of the big companies, like your Googles and Metas and things like that, they all have sustainability policies. And so therefore, they really are trying to do things that are more on the left side of this diagram, things that are low in terms of producing greenhouse gas emissions, things like that. So you'll see nuclear, which is going to which is a big component now. It's probably going to be even a bigger component when solar and hydro. That being said, most of the energy still is coming from fossil fuels, and you'll see natural gas being the biggest of those, and then also coal. Some of the policies that President Trump has issued, including executive order, are really trying to push coal, but countervailing that are goals, sustainability goals that the actual AI companies have. Natural gas is kind of like in between, where people are trying to say, okay, well, if we can't get access to these, sources that use less, produce less pollution, at least natural gas is going to be better for us than coal. But coal is still really a very big push by the Trump administration. So here's the 7 things, and we're going to go through each one of these. So the first one we're going to talk about is varying scale and function. So before, when we had data centers, it was primarily the ones at the very bottom, sort of the cloud data centers. And that has what has been throughout the country, particularly like in places like Virginia, for example. The ones that are more AI related are the hyperscale, the ones at the very top. But you do have bits and pieces of these others. So, when you look at like from the lowest to the highest in terms of like activity and demand, it's the lowest with the cloud, the highest with the hyperscale, and then you'll see this diagram here on the right, which really goes into like the difference in terms of tiers. So the best way to kind of look at it is that very top bullet, right? So, where they have like how many hours of downtime. And like at tier 1, so this is, it's like 28.8 hours of downtime. But look at, but look at the very top tier, it's only 0.04 hours annual downtime. And that is one of the sort of big aspects of it. The other thing that you can look at is sort of the cooling and utility paths. So for example, you'll see there's 2 independent utility paths up there at tier 4, and at the bottom, it's like single cooling and a power path. So as a manufacturer, you want to have some notion of what tier that data center is, because that will give you some idea of the size. And this tiering is from an organization called the Uptime Institute. And so if you're looking at somebody, like approaching one or to provide some components for it, you can definitely ask them what tier are they in, and that will give you some idea of the size and the needs from a component standpoint of that data center. So you can see this data goes from 2014 to 2024. It's going to be probably even higher in 2025. There's a really big surging demand, and all this is going to construction of these data centers. And again, AI data centers being really what's pushing the growth in this year and also last year. So another good way to look at this is what do the contractors say? Well, when looking at the different kind of projects that are out there, the contractors are saying that where they expect to spend most of their effort, it's on data centers. Then water, sewer, power, things like that. And then you're looking like all the way at the bottom is like retail, private office. You see those are declining. So that gives you a feeling for how active the field is in terms of construction of new data centers. This is I think a very interesting graphic from the National Renewable Energy Lab that just came out now. So it gives you a good idea of what the current infrastructure is throughout the country, sort of the hot spots that are constantly changing. And what do you need to build a data center? You need to have a primary power supply. Uh, it's really hard to connect to the grid, which we'll talk about later. You need fiber optic cabling, and you need a water supply. Though again, they are trying to make things more efficient. But now what's happening is the places that have been sort of like the hot spots, where it says primary markets, those are maxing out. And so what's occurring as there's more demand for data centers is that there's more and more emerging markets. including in our region. And if I was doing this map, which is from McKinsey, it's not from me, I would also add into this West Virginia, because I know that there's lots of plans there in West Virginia since I work there, on consulting, that to also put data centers there. And what they are is looking for space. Like you might remember, I showed that picture of that Google data center. Well, it's in Indiana, all right? They're really trying to find space all over the country in these more remote areas because of the grid and the constrictions in terms of straining the grid when they come in. So as I mentioned earlier, Trump wants coal to power the data centers. This headline talks about the tech industry may need to make peace with that for now. I think the tech industry still has a lot of control. They might be fine with, say, Trump saying it should be coal, but they still have a lot of autonomy as to where they get their power from. But like I said earlier, he did sign this executive order really focusing on coal sites and also looking at federal sites too. The challenge is that these things can really strain the grid and the power structure infrastructure. This is an analysis from Lawrence Berkeley National Lab. And you can see here that the hyperscale, remember I mentioned at the beginning, those are the ones, the AI focused ones that use the most energy, how big a percentage they are in terms of electricity use based on their projections, both in sort of the low and the high end projections. The same thing is true for water consumption. So again, if you look at that graphic on the right, you see how high the water consumption is that they are projecting. Now, there are some new technologies coming in to respond to this, and I'll talk about that a bit later. So this is a long-term issue that we've had related to renewable energy, is how long it takes to get a transmission interconnection. So if a data center, say, wants to put solar power in, wind turbines in, surrounding its facility to provide the power, the challenge that they face is that connection to the grid. If it's on the site, if it's collated with the site, then they don't really have to worry about those big transmission lines. But if they're trying to get their power from elsewhere in the grid, and make that connection, then you can see it literally takes years for that to occur. And that's again why they are trying to seek places that don't have as much a constraint on the grid. Even Pennsylvania's governor, Josh Shapiro, he has sort of threatened to leave PJM. That's the grid that we operate here in Pennsylvania. I'm based in Pittsburgh, because of the long time it takes for approval of these interconnections. So it's a very big issue and probably the biggest challenge. So the AI data centers are all facing scrutiny. One of the big ones is the additional costs that might occur for electricity because of the increased demand. As with basic economics, the greater the demand, the greater the cost for that electricity. So that is becoming a big issue in some states. Then there's this rural communities sometimes are not very big fans of data centers. You'll see here that this one is talking about in small town West Virginia, there's currently a battle between a data center and a local town. The other one is from a community that's in Southern Virginia. And the reason why is that most data centers, in terms of economic development and jobs created, is very small. I mean, it can be just a handful of people, maybe 20 people. So it's not, for a local community, a very big source of job creation. Now, one thing to consider on a statewide level is that job creation may be a big factor for manufacturers, and the degree to which that the states and cities negotiate with data centers to say, if you locate in our town, if you locate in our state, we want certain concessions. And one of those concessions that you could advocate for is that they use parts that are manufactured like within that state or within that region. And those do lead to more jobs, for people who are in those areas. But it's definitely not like a done deal that people want data centers, because from a cost benefit sort of standpoint, as an individual community, the strains, again, it might be more prices for electricity, it might be greater strains on the electrical grid, it might be more water consumption. It's not necessarily something that some people are a big fan of. So this is I think a good example is that this is a survey that shows that 93% of Americans support AI data centers. They just don't want them near them. And what are their key concerns? Environment, energy, increased traffic, and land use disruption, just like with anything that people build in a certain area. So again, this is this chart that kind of shows all the different parts of the supply chain, that where you want to start thinking about what is coming into it and where all those parts and components are going to come from. And then this is the supply chain itself, which you can see is quite large, right? So you have like first, like if you just the kind of the electronic sides of things, you have the semiconductors, IT infrastructure. Those are all going to those big data centers in the middle, the big companies that run these. Like Azure, which is like a Microsoft, Google, Amazon, Meta, you know, all the names that you have sort of heard of. And then there's also things in the energy sector, like where does the energy come from? And then the industrial equipment and parts. So in the report, we have a list of all the components that we were able to determine for these data centers. It actually lasts several pages. This just basically is an example from A through C. So if you are a manufacturer, then you should take a look at this and see if the kind of products that you currently produce are the kind of products you could produce, if they fit within this. And you'll see here it has a component, the NACS code, and then basically how it is used within those data centers. Now, I talked about emerging technologies. These are what they're trying to do. And this is also, I think, a potential market for manufacturers, is they're trying to be low carbon. Keep in mind that like circular economy in terms of waste heat use, hardware recycling, optimizing the software to make systems like more efficient for things like air cooling and moving to liquid cooling. And I'll talk about those more in future webinars. So here's some of the industry resources. The big trade association for data centers is called the Data Center Coalition. Green Grid is an organization that is trying to make things more environmentally sensitive. Uptime Institute seems to, they produced that chart I mentioned at the beginning. They're the kind of like more technical side of things. In terms of resources and funding opportunities, there's, and as far as we can tell, it's still active, this DOE program on manufacturing energy supply chains. And then ASHRAE has a whole technical committee that gives lots of details. So here's just the final thoughts. First, AI data centers are a potential major emerging market for small and medium-sized manufacturers. Our region is a major focus of AI data center investment today. It's important to understand, though, that this will not last forever, because as feasible locations decline, just like has happened, say, in Northern Virginia, they will go elsewhere outside of this region. So that what that means is you really need to sprint. If this is something that you think that your company can really play a role in, you need to really focus on it now. You should not delay. Things are going to be very different even like a year from now. It's like kind of a gold rush, almost like in the shale gas days, which were when I moved to this region. And then the energy and environmental challenges, are likely to increase just because there's so many of these data centers. But emerging technologies can help mitigate the impact that data centers play. And here's information on me in case you need to reach me. You're welcome always to connect with me on LinkedIn. I'm very active there, and you can email me here if you have any questions or comments.
looks like my head is missing from my from my screen.
You're headless, Tom.
Exactly. Yeah, you blew my mind with all this, Debbie. But no, thank you very much. I think that's great information. I loved how you wrapped it up. That I do think it's like the gold rush, and it does remind me of the Marcellus shale boom of the late right around 2008 to 2012. And we saw some manufacturers do a great job of getting into those businesses, making a small fortune, of growth. And then there were probably for the, 5 years after that big spike, a lot of companies saying, how do we become a part of that? And there were, and not that the latecomers didn't have a chance, still did, but they never probably caught that same great opportunity that the early adopters did and those who got in early. So I totally agree with you. That's why we're putting so much focus on this, because I think now's the time. A year from now is not going to be as opportune as right now is.
Yeah, like I said, I moved from DC to Pittsburgh to start as it's something called the Scott Institute for Energy Innovation at Carnegie Mellon. And the first thing I started working on in terms of the classes I was teaching there was one on shale gas policy. And and also the Energy Innovation Center that I worked for was also super active in this area. Um, and it is something where you really want to sort of think about it as a potential market opportunity. Markets sort of come and go. But right now, for example, I think if you're in, I was just reading something this morning on LinkedIn that talked about solar in Pennsylvania and how that industry is now, sort of facing challenges, because of the changes in policy. Well, if you're making components for solar, uh, you know, maybe you can say, okay, well, can we figure out a way to make these like really active for data centers? If there's a way to like rethink about how we're manufacturing products. So as technology shifts, as it often will, I think it's really important to prepare and strategize, when we're thinking about AI data centers.
Yep. No, I agree with you. All right. So there are a couple questions I'm going to share with you. What are some of the major challenges to seeing this development take place, such as workforce, public pushback, funding, etc.?
Mhm. So I think probably on the energy and environmental side of things, if you're somebody who works in that world, like if you do things that are related to uh, energy storage, anything related to renewables or nuclear, that's something where you really need to think about either if you're not in the market now, sort of like maybe moving to that market where you're focused specifically on the AI data center needs. So I think if I was a manufacturer, I would start reaching out to some of these companies and uh, particularly ones that are locating within your state to better understand, what their needs are. I think there's definitely, um, from just a public relations kind of standpoint, there will be something where it's really good for them to show that they're using regional and local manufacturers for the ones that are in our region. And then from an international standpoint, a national standpoint, realize that what you develop here, can also be sent to all these other places in the world that aren't as big of a manufacturing base as our region is. So I don't know, let's just say take Iowa, you know, they probably, I suspect, don't have as much manufacturing as in this part of the United States. So by developing a pilot here, you are able to, uh, to set markets for when when it goes beyond our region and goes to these other regions. So that's, I think, a sort of a good way to think about it. And then I think the companies are also always looking for innovative ways to respond to the energy and water needs. So if you're like a startup, and you're working on, I don't know, some sort of like robot or things like that, uh, then if you propose something that will help them meet those goals, then I think they're very likely will be interested in hearing what you have to say. And because they are really, sort of pretty desperate, I would say, to respond to those needs. So think about it from those standpoints. And then when you get into things like like structural things like steel cabinets, like maybe if you're making a steel cabinet for, I don't know, homes, well, can you modify your manufacturing process so you instead start manufacturing those steel cabinets that are suitable for the computer industry?
Yeah, no, I think that's great advice. And I do want to mention, I forgot to say it, I put it in the chat, but if anyone has any additional questions, you can type those right into chat and we will cover those. I do have one more that I will pass on for you to get your thoughts on, Deb, and then if anyone else wants to type anything in. So the next question is, we hear there is a race against China. They announced their moonshot AI. Is that a big threat to AI development in the United States?
Well, I think yes, is I would say the bottom line is overall, I've done a lot of studies actually on US competitiveness, and this is definitely a big kind of global market, and AI data centers are being built, like all over the world. Everybody sort of has the same needs. So, if they can do things, if they can meet the needs in China for these manufactured goods, all the ones that are in that table that I showed you like part of, then some of those parts are quite likely to come from China if the need is not met here in the United States. But there's also pressure on the companies, of course, because of, Trump's push for tariffs and things like that, to use things that are produced in the United States and to, particularly from a state policy perspective, you know, uh, parts that are components that are produced within the states that the data centers are locating in. So overall, we've been in competition for China for everything related for science engineering for a long time now, for decades. As the investment in the United States in science engineering decline, that competition from China is just going to really increase. And I should also say that some of the other countries, I wouldn't say China, but some of the other Southeast Asia countries and some parts of Europe, when it comes to equipment that's more energy efficient and less water intensive, those products are being produced in places like Japan and Germany and some of those countries because they don't have a choice, right? So for them, we are lucky in the United States. We have lots of energy resources, lots of energy options. For those countries, they don't have them. And as a result, that's where they focus their technology activity is on making things that use less water, that are more energy efficient. So we're definitely in competition with them for for any of those kinds of products.
Great. No, I think that's really important to hear. Okay, I don't see anything extra. I guess at this point, I did put the link. If you have not already downloaded the report, please click the link. I put that in chat. It's also on our the website that I shared earlier. Last thing is, what would you, other than downloading the report, because I think that's the first starting point I would recommend for a company. What would you say is kind of that next starting point for a company who's just trying to figure this out? Any thoughts?
Yeah, so I would say, like when you look at some of the diagrams, like whether it's, cooling, whether it's anything built from steel, uh, things that are anything that's energy related, water use related. If you are a company that operates in any of those spaces, then I think you should really kind of like, if it was me and if I was at a manufacturing company, I would have sort of a brainstorming meeting and sort of think, okay, well, let's look at this list of all the components. Is there anything that either we already produce that could be modified? Is this something where we can maybe change our process to produce like a new widget that would sort of meet these needs? And if that's the case, then I think the next step is beginning to have conversations with these people who are constructing these data centers. So it's not necessarily the people who are at, say, Google or Meta or things like that. They hire contractors, right? And the contractors are the ones who build the centers. And you need to begin reaching out to them to see if you can, capture part of that market. Because right now, uh, we're sort of at the early stages. There's a few that are either under construction or under discussion for discussion, and we're at the very early stages. Uh, like I said, but they're talking about, I think if I can try to remember the number in West Virginia that I heard is maybe like 20, 28 data centers that are being considered. Well, that's a lot of data
Yeah.
centers, right? And for a small state. And um, so if you can get in early and if you can, start to show that you can provide value to these organizations that are constructing these data centers and are the big like contractors that put all this stuff together, then then I definitely would sort of take those steps now. But I think the first step is sort of like just sitting around, brainstorming meeting, looking at the document that's there. Like I said, what we have today is a more general document. But you'll get more information in terms of these other markets and these webinars that are coming up and the products and the NACS codes and components that are listed there.
Yeah, no, I think I totally agree with you. And I think that brainstorming session is a great idea. And the good thing about the Energy and Manufacturing in Appalachia program, we're made up of MEP organizations all across the Appalachian region. And everyone has staff that could come and talk to you, be a part of that discussion, or help to answer questions that maybe, come out of that brainstorming session. So, please reach out to EMA whenever you are ready to kind of do those next steps, and we'd be glad to help you. So again, thank you, Deb, and it was very informative, and we look forward to the next iteration on diving a little deeper into, let's see, what do we say the next one is? Is it energy or cooling?
The next one is energy.
Energy,
So
yes.
yes,
So,
yes. So that looks at sort of both the source of energy, but also in terms of like, solar or wind or whatever it is, natural gas. And then also the energy use within the centers, which is a very, very big component because they have those uninterruptible power supplies, lots of different things. Because again, they have to, there's no downtime if you're an AI data center, right? It's basically, it was like 0.02 or something if you saw on that chart. So that's what the next webinar will be on.
fantastic. Great. Well, thank you very much. And thank you to everyone who joined us today.